So K5 means we're going to have 5 vertices, and each vertex is going to have an edge that goes to every other vertex. So this one will look like that. I'm just going to continue on with different colors because it gets kind of hard to read. So this vertex here is going to go to here, and then this vertex here will go here, and it's already connected up there, and so just one more. So this vertex here will connect here, and it's already connected to all the others. So there's your complete graph, and you can see the star inside of the square, or pentagon, I should say. This here, K42, it's a bipartite graph, so you're going to have 4 vertices here and 2 here. Again, I'll just use different colors. So this vertex here has an edge going to both of those vertices. And then this vertex here is going to have edges going to those 2 vertices and continues on, right? So this vertex here, here, and here. And then last one, this vertex here, here, and here. So they're kept separate. All right, and the other one that I skipped in this section was this one. So is this possible to have this graph that has all of these different vertices, 10 different vertices with all of these different degrees? Well, if you add all this up, the sum is 43. And since it's not even, it is not possible to have a graph like that. So no. So these are included in your notes, and they're just practice problems. So let's just do them. Let's just make sure we're feeling good about like drawing different graphs, if there are different graphs. So this has 4 vertices. So 1, 2, 3, 4. Okay, so then I'm going to have different degrees on these vertices, 3, 3, 3, and 1. So I'll make that one be the degree of 1. And so then I'll make this one of degree 3, right? Because it's got 3 edges coming out of it. And then if I connect these and then put a parallel edge, these both would have degree 3. So that would work. There's many different ones. So let me just draw one more. If I make that my degree 1 vertex, and then I make this, so this has a degree 3, and then I put a loop on each of these. Doesn't say simple, so I can put loops there. The vertices of degree 0, so a degree 0 vertex has got to be out here, and there's only 3 vertices total, so then I've got to have parallel edges, and then maybe a loop there. So again, play with these, maybe turn the video off and just kind of go through them to see if you can make one. So here we go. We've got 5 vertices. So 1, 2, 3, 4, 5. Okay, so I'm just going to make this one my vertex of degree 1. And then I'll make this one of my vertices of degree 3, right? You don't have to write this. I'm just making sure you see what I'm doing. So if I make this a degree 3 vertex also, then this will come in, and this would be a degree 2 vertex. I need that, but I also need a degree 5. Oh, I know, this degree 3, I'll just put a loop out there, and that'll make it a degree 5. So if I have 4 vertices, and these are the degrees, I always want to make sure I can check to see. I should have done this here. Does the sum of the degrees equal an even number? This does not, right? This gives us 6, 9. So this gives us a degree of 9, and you can't have, there's no graph that has a degree that is not even. So let's just check this one here. So this gives me a degree of 7. And so I'm thinking total degree, right? The total degree of the whole graph. Set no graph for that one either. So simple graphs, you know that means no loops and no parallel edges, right? Parallel edges, and I just drew a parallel edge like here, up here, right? So these are parallel edges, can't have that. So what do I have? I've got degrees 1, 2, 3, and 4 with 4 vertices. So I can make one of them a degree 1, right? And then if I make this one a degree 2, Wait a minute. So I could try making this one of degree, well, if I can't do a parallel edge, I don't think, and I can't connect with that one. The only way I could possibly do it is with parallel edges, so it is not possible. With, whoops, possible. Possible. It can't do it, not possible without, possible without having parallel edges or loops. So simple graphs are a little more challenging. All right, so let's look at this one. So I've got a simple graph. Again, no parallel edges or loops. So they say all the vertices have degree 3 and there's 9 edges. Okay, so total degree of a graph is always equal to 2 times the number of edges. So if we put in 2 times 9, that gives me 18 is the total degree of the graph. So if I've got total degree of the graph is 18, and I know that the number of vertices times all have equal the total degree divided by, how do I know? Oh yeah, they tell me they're all degree 3. Degree 3. So that's going to give me total number of vertices, which is 18 over 3, right? Because all the vertices are degree 3. So that means that there's 6 vertices. So I really needed to do quite a bit of work to find out how many vertices I have to be able to draw. Okay, so let me make room here. So I'm going to draw 6 vertices, and each of them has to have a degree 3. 1, 2, 3, 4, 5, 6. Going to leave some space in between them all, right? And so if they each have a degree of 3, let's think about that. So I could go here, here, and say here. And then I could go here, here, and then here, and here. Oh, that's got a degree of 4. That's not going to work. Hold up. Okay, I'm going to go back. So I've got 9 edges. So maybe draw like this. Okay, so here, and let me start just by making a box and see if I can put some crisscrosses in between. So this has degree 3, that has degree 3. Let's do this and this. So there it is. So 9 edges, and I've got 6 vertices, each of degree 3. Okay, K6, that's going to be 6 vertices where each of them has an edge going to each one of the other vertices. So 1, 2, 3, 4, 5, 6. Yep, got it down. So then here we go. So then, whoops, this will go here, here, and here, and here, and here. Then I go to the next vertex here. So it's going to go here and here, and it's already going there. So then the next one, I just make it go to all the other vertices. And then what else do I have? I've got this one. It needs to go here. All the other places are filled in. So there's just one last one. And I can see the star. Let me make sure I got them going to every one. I do. There we go. Okay. K43 is that bipartite graph. So you're going to have 4 vertices here and 3 vertices here. So each vertex here goes to each one of those 3 over there. So this vertex here goes to those 3. This vertex here goes to those 3. Whoops, try to get a different color. And then this vertex here goes to all 3.